centered, not centered, but the one right there. That thing. So we know that this is our fraction bar, and I'm guessing that the setups for all three of these styles are really easy. You have the fraction bars and you have the multi-equal. I know that's so stupid, but it works. So you've got your fraction. You have your fraction, which means at this point, you're still doing the same stuff. Cross multiply. When you cross multiply this, 12 times the 5x minus 1 equals 7x times the 2x plus 2. Right. Distribute in for both of them. We have a 60x minus 12 of 14x squared plus a 14x. Now comes the part of that little bit of the remembrance from an Algebra 1 class. Remember, this, as you get further in geometry, especially second semester, they're going to assume, without trying to make an angle side-side out of you and me here, but they're going to try to assume that you guys had all remembered at some point in time that you've had Algebra 1. Because, honestly, we've been solving equations. It hasn't been anything too crazy. This is where they will throw some of these quadratic style equations at you. From time to time, I know that in here they show it. I know that in right triangles we'll see it. I know that in some of the area problems we'll see a few of them. And then I know for certain in circles every once in a while we'll see them as well. The quadratic style problem shows up. What that means is, when you see x squareds and all that, you have to get one side equal to 0. Since the x squared's coefficient, remember what a coefficient is? Yeah, the number in front of it. So the coefficient in front of the x squared is 14. It's positive. Since it's positive, I'm going to move everything from the left to the right. Okay. So I'm going to subtract 60x and add 12. So 14x squared, I'll get minus 46x plus 12. From here now, I have what's called a quadratic equation. A quadratic equation is an x squared term. And in this case, it's called a trinomial. It's called a trinomial because there's 3 parts to it. An x squared, an x, and a constant. Yes, sir? I subtracted the 60x. Okay. I just did it right now. I'm sorry. So from there, you have to start thinking about factoring. And factoring, if you guys recall in Algebra 1, was one of the mainstays that you guys had kind of over and over and over and over again. No, is that why you're late? Now, one of the things that happens when you're dealing with quadratics, when you're trying to factor something, the first rule of factoring was always to look for a GCF. Remember what a GCF stood for? Yeah, greatest common factor, good. Now, if I'm looking at that, I have a 14x squared, a 46x, and a 12. They don't have any variables that are the same, but they do have numbers that are the same. I can divide all of those numbers by 2. Okay. So I factor out a 2, and I get 7x squared minus 23x plus 6. Now this gives me one of 2 ways of trying to remember how to solve quadratics. One of the ways that we solved quadratics in the past was just via factoring. And when we did the factoring, we did it in a couple of different methods. This is the more complex style, but if you recall, we've done one like this also. Just off the side here, if I say it's x squared, excuse me, minus 10x plus 21. When you had to factor that, do you guys remember how we did that? we would say what times what was positive 21, but yet when you add them together, you get negative 10. Okay. So what are your factors of 21? 1 times 21, 3 times 7. One of the things you had to also remember is that if you're multiplying two numbers together to become positive, that means the two numbers are either both be positive or they'll both be negative. Well, in order for them to be positive multiplied but negative adding, that means they both have to be negative. So this was that negative 3 times negative 7. So you wrote your terms then as x minus 3, x minus 7. Your terms were the things that were in parentheses. Your zeros, the answers, were when you set them equal to 0. You get 3 and 7. 3 and 7 are what makes that equation equal to 0. This whole idea of factoring and solving for x, finding zeros of what is this trinomial, this quadratic equation, is something called a polynomial. When you find zeros of polynomials, that's kind of the whole, well, it is. It's what they call the fundamental theorem of algebra. Stuff you talk about next year. Yeah, actually, one of the things we do next year is that all you really do first semester in Algebra 2, factor, factor, factor. Trinomials, binomials, polynomials, all the different nomials. But we do a lot of stuff. We just work with those things. What that means is that for every nth degree that you have that many zeros across the complex numbers. What an nth degree means, this is a squared term, so it's the second degree, which means it can have up to 2 zeros. And that's what happens. So we spend a boatload of time on that again next year. Geometry is kind of weird that it kind of goes away from that basic math stuff that you did last year with polynomials, and you worked with quadratics, you did the graphing, you did all that stuff. That's what this equation is. It's just a parabola that's up like a cup. What you're trying to figure out is what values of x does it cross the x-axis. You're trying to find its zeros. And that's what that's called. What's different now is that you have a leading term coefficient that's not equal to 1. So you can't just say what times what is 6 to add together to get negative 23. You have to do what times what is 42 that adds together to get negative 23. Okay? It's not that difficult to figure that part out because you're just going through your factors. I mean, what's half of 42? So 21 times 2 is 42. Make them both negative. They add together to get negative 23. Okay? So when you had trinomials that did not have a first term equal to 1, you had to do extra math. And what we did was we set it up in a way that we would call it factor via grouping. It might look familiar. You have 7x squared minus 21x, what's the 2 first? Minus 2x minus 21x plus 6. What we're doing here is we took that middle term of 23 and we split it into the two terms that multiplied to the tails and added to the middle. This was all procedural last year. And then you would factor it via grouping. What I mean by that is I put parentheses around the first two terms, and then I do a same change opposite, and then go to the second two terms. The reason why I do that is to remind myself to factor out a negative. You don't always have to do that. It's just one of those, this is kind of the worst case scenario. And now you do GCFs twice. What's the GCF of 7x squared and 2x? 1, but what else do they have in common? 2 doesn't go to 7. So. What about an x? They both have an x, right? Factor out an x. Okay. What do I have to factor out of this to make it look like 7x minus 2? How do I turn a negative 21 into a positive 7? We have to divided by? Positive or negative? Negative. So I factor out the negative 3, I get 7x minus 6. I'm sorry, minus 2. Are these two parts the same? That's good, because they should be. You write it out, and what are you left with? And now you're factored. Then you set each individual term equal to 0. Once you get it, your term therefore generates the 0. Okay? This is all algebra stuff. Add 2 divided by 7. Add 3. Those are your two possible zeros for answers. Okay? Those are your two possible zeros for the answer for that. In order to check to see which one works, you just have to go back to the original, way back up here. Just trying to grab the one thing. And you would check it just using your calculator, see if they both work, if only one of them works. Okay. What's that? It is. This is one of the more complex problems we've had all year. I think it's probably the most work aside from the proof that we've had to do. I think the two preceding it were easier because you didn't have trinomials. All you had were binomials. You guys catch that? So all you do is factor out an x. This one just takes a lot longer to get through. Now, would I put something like this on the test this week? No, not with a leading term coefficient of 7. But could I do something where it's just an x squared because it's just a factoring problem? Sure, absolutely. I don't know that. Let me show the other ones that were like that real quick. The other ones weren't as much work as that. As you go through and you set up your heart or your kidney or your blood, whatever you want to look at it as. 7x over 5x, 10x minus 4 over 6x. When you cross multiply this one, you're going to get 42x squared equals 50x minus 20, so 50x squared minus 20x. Yes, ma'am?
Okay, so I switched it, but I got 42x not squared and then 50x squared.
You're wrong. Because x times x has to be x squared. Okay. It'll have, I mean, if you wrote it as 5x over 7x, 6x over 10x minus 4, you'll still get the same exact thing if you cross multiply. But you have to remember, when you multiply x times x, you get x squared. Okay, I'll put it over your phone. Now, set it up, set one side equal to 0. Means I'm just going to move everything to the side of 50x squared. And I get 8x squared minus 20x. In this case here, since it's not a trinomial, I subtracted 42 from 50. Since it's not a trinomial, I don't have to worry about multiplying ends together to add to the middle. I have two parts. I just have to look for GCF. What does 8x squared and 20x have in common? 4x. Good. Take out the 4x. You get 2x minus 5. You still have two parts now, two terms, if you will, that you set equal to 0. When I set those both equal to 0, you have two values of x. 4x equals 0, or 2x minus 5 is 0. Which means I have possible zeros at 0, or add 5 divided by 2, 5 halves. Okay. And then again, it's the matter of going back to see if those could be, bless you, if those could be valid answers. Can I have 0? What's 0 times 5? What's 0 times 6? What's 0 times 7? So can I have segments of 0? So can I just throw out 0 right away in this case? This is an example that 0 won't work. Right? 0 won't work. And then I would just check with 5 halves. I bet you 5 halves works. 2.5 is the fraction, or decimal. Right? You're still doing all the same stuff, but you have that one added step at the very end with factoring out a GCF. Okay? And it's the same thing. I think that very well could be. It's nothing too crazy. And this one's even easier. I think this one was the quickest of them all. Again, you've got your fraction bar, so you have 4x, 5x, 4x plus 8, 6x minus 10. Cross multiply, we're going to get 24x squared minus 40x, 20x squared plus 40x. When you have x squareds on both sides, you want to make sure you set one side equal to 0. So I'm going to move everything from the right to the left. Subtracting those over, we'll get subtract this over. We'll get 4x squared minus 80x, 0. I think that color piece came from that shot. And once again, you're back to GCF. What do they have? That's a 4. What do they have now? 4 and how about an X? You're right, they have 2 goes into both of them, but well, great is you have 4, but they also have an X. They got 4x, you got x minus 20. Your 2 terms. 4x could equal 0, x minus 20. What times 4 equals 0? 0. Then this one has to be. We can't have 0 7. Now, hey, at least you get to leave. You don't have to deal with it for a few days. One of the things I want you to remember is that if you get 0 for an answer, it doesn't necessarily mean that it's always not going to be the answer, okay? Because there's going to be times eventually, like when we get into circles, that you can have segments of like x plus 1, x plus 2, x minus 3, or x plus 3, I don't know. I'm just making stuff up here. You could get stuff like this, and let's say you get the value of x was equal to 0. You could get segments that work. By 0 plus 1 is 1, 0 plus 2 is 2, things like that. So don't think that it doesn't necessarily have to be automatically excluded as an answer. Okay? It just doesn't happen to work in a particular problem. And plus, next year when you get to these things, you're going to have to graph this. No, you have a 0 here, and a 0 at 20. X is symmetry at 10. And then that'd be what, 10, 40. They got 400, I think. The vertex way down here. So I mean, you guys will be doing stuff like this later on. So it's not that you haven't seen this before. It's just that you haven't seen it recently. That old adage that I've talked to you guys before. I didn't teach you how to add, subtract, multiply, divide, and I know how to solve the equation. We'll do more of these as they come around, but I won't make anything too crazy for you guys, all right? Other than those 3, were there any other questions on the stuff from last night? I think the rest of it was pretty straightforward. You got the nice fraction bars for 2 of them, then you just have to love the other one. We okay with that? Am I right? Kind of assuming that? I hate to assume, but I know where I'm getting at. So hold on to that. I want to talk about a little bit more about what the test is going to be like. So, what I'm looking at for this, when we start talking about the whole idea of our test that we'll have on Friday. Now, are you doing it tomorrow? You have to take it when you come back then. You don't want to do that. It's your call. I mean, I just know that. I just know how it goes. We'll play it by ear. Anyway, so what we're talking about with this chapter 7 stuff, is that we've only had 4 sections. Really think about it. We've only had 4 sections. It's probably the shortest chapter in the entire textbook. We had 7:1, 7:2, and then 7:5. 7:5? Was it 7:6? Yeah, 7:5. 7:6 is what we just did now. Excuse me. Now, as you go back and start thinking about what did each section talk about, 7:1 was all about just setting up ratios. It was all about setting ratios together, cross multiplying, solving for x. That was nothing. And lo and behold, what have we been doing since 7.1? Solving ratios, solving ratios, solving ratios, solving ratios. That was always what we were looking at. Bless you. When we got into 7.2 is when we added the idea of this whole thing called similar. We started talking about similar figures. When we started talking about similar figures, that's when we started to introduce or reintroduce you guys the idea of that congruency statements, but we talked to them in terms of a similarity statement. So we were able to go back. Gosh, put away your phone. Guys, I'm telling you, this phone thing is really getting out of hand. Believe me, focusing on what you're doing will help. When we get into that, as you guys saw, we started talking more about that quiz, about the mess-ups on that, was the idea of not falling back to the letters. Fall back on the letters of your similarity statements. You know, your A, B, C, D, similar to W, X, Y, and Z. How do you write up the ratios? How do you write the letters together? Go in order. Sorry, you were saying? No, go ahead. I jumped all over that. Sorry. I was just being rhetorical, but I appreciate the effort of just jumping out there and saying, "Oh, it's A, B, B, oh." But that's the idea, guys. It's, can you take a similarity statement to understand what matches with what? Okay. Where do you go? Oh, you just now noticed it? Oh, eventually. I've been getting there. Just put his in there. Jerk. I just suck. So we did similar figures. We also did in that one, we talked about ratios of sides. And this is the one where we talk about the ratios of the angles in a triangle. We talk about ratios of perimeters. Okay. We talked about those in there. And before I go too much further here, I've got a couple of quick examples, stuff like that I'd like to go over. All the time.
Okay, you said it's always Monday. Because I'm like, I know it's not Monday.
It talks about the ratio of measures of the angles inside a triangle. So that's also the same vocabulary or the same verbiage, if you will, same directions that we had on our place. You guys okay? Right down, right?
This is how much.
No, it's just you just right now.
Oh my God, there's a lot of videos. January.
For example,
How do you feel?
the ratio of the measures of the angles in a triangle are 8 to 3 to 4. Anytime we dealt with the ratios of angles, that always meant that inside the triangle, there was an 8, a 3, and a 4. But those 8, 3s, and 4s were all being multiplied by the same exact value. That value was the commonality between them that we just don't know. So we don't know what it is, what do we put? There you go. Which then created a problem for us, which was pretty easy. What do all the angles in a triangle have to add up to equal? There you go. So 4, 3, and 8 add up to equal how much? Good. So you get 15x, 180. Divide that out, what do you get? You get 12. But also remember, the questions themselves won't always just ask you to find the value of x, find the common value. They're going to ask you to also figure out what were the angles. So if you have to figure out what the angles were, that means you have to go back and substitute in 8 times 12, 3 times 12, 4 times 12. 96, 36, and 48. Finding the ratios, working with ratios of the angles. Angles add to 180 because they do. Okay. What's different between ratios of angles and ratios of sides? Unless it tells you to. So on number 2, it talks about the ratio of sides. Let's talk about the ratio of sides. We're given it at 9, 12, and 5, and the perimeter of the triangle is 130. This idea of the ratio of the sides, for the work of that versus the work of working with the ratio of the angles, it's the same exact problem, except it just adds. It tells you a different sum. It tells you it adds to 130. So 9x, 12x, and 5x. What is that? 26x, I believe.
Yeah.
Divide that out, and you get. And then again, if it asks you to find the side lengths, you have a 9 times 5, 12 times 5, and a 5 times 5. 45, 60, and 25. Now I kind of ran short the other class here. Flip over to number 9 real quick. I'll show you a little different way of doing the ratios here. Let me draw this one up. I forgot to make a scanned copy of this. Now, when we first talked about similar ratios, I think when we first talked about similar triangles, before we talked about how to prove them, one of the things that we talked about is that if triangles were similar, their sides have the same scale factor, as well as their perimeters. You guys remember that vaguely? So if you're going from left to right that has a scale factor from 4 to 3, we can use that scale factor to find each piece of the missing triangle. Or, knowing that the scale factor of the sides matches the scale factor of the perimeters, I can just use perimeter to find it and just do the math once. So what I'm getting at here, well, what is the perimeter of triangle CDE? What would you do to figure that out? Yeah, add them up. What's wrong? Now you're kind of like, bright lights. I don't know. Get more sleep. All right, don't get enough sleep then. Don't get too much sleep. Good conversation. So if we add those up, we get 13 and 22 is 45, or, I'm sorry, excuse me, 35. 35 and 29 is 64. So the perimeter going from left to right, my perimeter here is 64. The perimeter here is, when it gives you the ratio in terms of the colon, 4 to 3, what goes in the numerator, the 4 to the 3? 4, good. So if I'm going with my ratio of 4 to 3, I went from left to right, that means this would be 64. So, cross multiply and solve. You get 48 for that? Cool. Now you can do it that way. Let's say you forget that perimeters have the same scale factor. Can I do the same ratio 3 times? 4 to 3 equals 13 over something. 4 to 3 equals 22 over something. 4 to 3 equals 29 over something. Figure out those 3 somethings, just add them up. That also works, but it's just sometimes if you remember, there are shortcuts. And it just so happens to be one of the few shortcuts that we have. Yeah, that's what you did. Yeah, that's what we did. I did 64 divided by 4, and I knew that was 16, then I did 16 times 3, which is 48. Or you do 3 times 64, hit enter, divide by 4, and you still get 48. It still works. Okay. Now, going back to, I just want to make sure I showed you guys that before we ran out of too much time. Go back to the other side now real quick, and let's look at the differences between numbers 3 and 4. I'm going back to talking about scale factors and stuff like that, because these are the things we haven't talked about in a while. I want to make sure we hit these. The rest of the stuff that's on here for this evening, those should be pretty easy for you. Now, if we're talking about a scale factor, going from A to B, we're talking about scale factor going from A to B. We don't know lettering. It wasn't told to us lettering. And since we're only given 2 side lengths, when we're trying to figure out the scale factor, does it matter whether or not you choose the 36 or the 25.2 as your A value? So if I choose the 36 is to which value on the other one? Why does it have to be 20? The 2 larger, yeah, because that's where you're getting at. You just have to say it louder. You're fine. You're right. Or you could have done the 25. Either one of those will simplify to give you the same scale factor. I do want to show you one thing with the multi-views. If you chose to use 25.2 over 14, if you do that in the calculator, try that with the fraction bar real quick. What's that? You can, but it's not going to give you the fraction. For $15, you really need to get one. What was it? Was it 14?
Yeah.
Thank you. When I hit enter, the calculator, I think all the calculators give you 1.8, right? Do you know how to switch that to a fraction on that calculator, multiview? Yeah. You guys, you have the double arrow button, I believe will work, or you hit the fraction of decimal. The MD, or I think FD, excuse me. I have to do this. And you should get 9/5. Okay. If your primitive calculator probably said 1 in that little barrel, that little L button, 4/5. Mixed numbers don't exist. Yes, sir. Yeah, you have to use that. Yours, there should be a button that says math. If you hit enter after you get 1 point, after it gets 1.8, it should work. But I'm telling you, that calculator won't do you any good with trigonometry because it won't do any simplifications. You'll have to crank it all by hand. They're $15, guys. I've been harping on this all year. You really want to get that. Okay. I just wanted to make sure that you saw that. I just want to make sure you guys saw that with the decimal because that does show from time to time. Okay. What changes with the next problem? The next problem talks about, you got 4 sides, but the next problem says it's going from B to A, so you're going from right to left. So you have to pick a segment length on shape B and put that over the segment length of shape A. Now, does it matter which segment length you choose for B? So if I choose 9 for my B value, what value do I have to choose for the other one? Good. Remember, they have to correspond. They have to correspond to make it work with the small to small, large to large, however you want to do it. Okay. It's just kind of a big rule that you have to follow when you're dealing with scale factors and similarities and stuff. Okay. 5, 6, 7, and 8 all give you similarity statements, which means what should you do in order to solve them correctly. Write out the letters first, guys. I cannot stress enough the importance of writing out the lettering for your similarity statements, because that's how you math correctly. And mathing correctly is usually a good thing. 4 out of 3 dentists recommend that. Buckner, I appreciate the offer of trying to figure that problem out real quick, but when I have like a bunch of people call back and going, what? Wait, how's that work? So sometimes, Kleckner, good morning. But I'm on your left. No, that's A and B. Kleckner, I got a good story. You're gonna like this one. You guys, any of you guys remember when your younger brothers or sisters were like in kindergarten? They called popcorn words or sight words or baseball words or whatever. Our youngest, Moose, he's in kindergarten right now, and he's coming home with all his weekly words and whatnot. And he was trying to sound out his words last night while he was doing his homework. And he got to one of the words. He goes, "Daddy, what is this spell?" I'm going to read you the letters. I'm like, okay. He goes, W-H-A-T. And I said, what? No, Daddy, I just asked you what it spells. And he goes, W-H-A-T. I go, what? Daddy, what does it spell? I go, what? I'm asking you a question. It was great. Oh, guaranteed. Then he realized, I'm like, Goose, it spells the word what? Oh, that's why he kept saying that. No, I heard that one. It's really cool. It's called, I believe it's called Bravely Sounding Out or something like that along those lines. Man, it's just fun. I love messing with my kids. Finish this one for tonight, and we'll do some more of this kind of stuff tomorrow. Our other one, we have a 6, or sorry, 5. One of them's 5, the other one's 8. They turn 6 and 9 next month. Yes, ma'am.
I think I can say
Nope, because we're trying to figure out the scale factor. The way to cross multiply really is to see. Fine. We give our scale factor. And they'll be wrong. It should be the same. Alright, so here's the thing. You're going from 9 to 24. 9 is the smallest side. So it has to correspond to the smallest side. It's the same thing. We get those board sheets. We got those worksheets too. Yep, that's awesome. That is really, really funny. What? What? That's awesome.